LiDAR data processing scenario is 90% about data reduction. How do I take this multi-billion point capture of a scene and turn it into data I can measure with, data I can display on some kind of a display or stream over the internet. And so a lot of the activity there is just data reduction and techniques to do that. The cultural activity around everybody having a 3D capture of a scene, whether it's an object at a museum, who owns the right to that when I do that? If I'm the one who captures it, what does it mean when I captured it and then I take it to my 3D printer and print it?
Welcome to another episode of the Mapscaping Podcast. My name is Daniel, and this is a podcast for the geospatial community. My guest on the show today is Howard Butler. He has his own consultancy, Hobu Inc., and Howard is also one of the developers behind the Point Data Abstraction Library. And today on the podcast, we're going to be talking about point data, point clouds, and of course, PDAL, the Point Data Abstraction Library. Thank you very much to OSGeo for helping make this podcast episode possible. I really appreciate your support. If you're not familiar with OSGeo, go along to osgeo.org and check out some of the work they're doing. Also, they have a load of incredible projects that they help support. All open source, all worth checking out. I'll put a link to them in the show notes to make it a little bit easier to find. Hi, Howard. Welcome to the podcast, and thank you very much for taking the time to talk with me today. Much appreciated. Today, we're going to be talking about the Point Data Abstraction Library, or PDAL. But before we do that, would you mind just sort of briefly introducing yourself and perhaps giving the audience an understanding of how you got involved in geospatial?
Yeah, my name's Howard Butler, and I have a consultancy called Hobu Inc. We're located in Iowa City, Iowa, United States. And I started doing geospatial software as an ArcView user during my grad program, studying agricultural engineering, and was doing some software development there in support of my program. And once I got done with school, I liked it quite a bit. I just started doing more and more software development. And as time had gone on, out of my first job out of school, I was doing geospatial software development with a lot of Esri tools, started doing a lot of open source software as a means to achieve what we were trying to do. Got very actively involved in open source geospatial as part of that. Kind of took my own consultancy, Hobu Inc., and started doing open source software as a consultancy. Eventually ended up doing point cloud data. Got a contract with the Iowa Department of Natural Resources, and they were one of the first states in the United States to capture a LiDAR collection for the whole state, and they needed some software tools to deal with their data. And so we wrote some software called LibLaz in support of that. And the U.S. Army Corps of Engineers found this library. It was open source. That was kind of what we did as a consultancy. And it was just myself and a few subcontractors at the time. They found this library and they're like, this looks really interesting. We want to do that, except with a lot more data in a data warehousing scenario. And so Dave Finnegan and Mike Smith from the Cold Regions Research and Engineering Laboratory up in Hanover, New Hampshire, supported our development of the initial versions of PDAL or PDAL, any pronunciation fine. It's got the same problem that GDAL has. That's how we started out. PDAL's niche is focused on point clouds with a geospatial sort of tilt to them, and the problems of interacting and processing point cloud data within a geospatial context.
So I want to get back to PDAL and GDAL in just a minute and sort of compare and contrast those two things, because I think a lot of the listeners will understand what GDAL is and what it's used for. And I think that might sort of help set the stage for talking about point data, the Point Data Abstraction Library. Just before we do that, I want to ask, when you started working on point cloud data for your own consultancy, were you just filling a gap in the market, or is it something that you're interested in? Did it provide some sort of interesting challenge for you technically? Or is it simply, okay, there's a product that we can, supply to the market?
It was certainly a niche that wasn't well covered by open source software. So in that sense, it was a nice green field. Software developers like green fields to program into, I guess. I had always been interested in topography and morphology as a scientific endeavor and as part of my research in university. And so I liked doing that stuff. And LiDAR as a means to acquire really high fidelity information was really great. I mean, the data volumes were humongous at the time, and writing software and specialized techniques to be able to attack that size of data and that kind of unique data was a very interesting problem to go after. And so we started developing mostly data management and data access and data compression tools. We worked with Martin Eisenberg of Laz Tools to help put the Laz Zip library out there as a open source data compression for LiDAR. We did a lot with data organization and access with a library called Entwine for allowing data to be streamed. And of course, PDAL or Poodle for kind of data management. As far as GDAL is concerned, so GDAL and its complement OGR has the vector and the raster kind of data types covered in terms of software tools, but point cloud's kind of a bad mix of both of them, I guess you might say, in the sense that point data themselves, to treat them as vector data, tends to introduce a lot of overhead, talking about millions or billions of points. And, geospatial point databases with billions of points in them are difficult to deal with, of course. But it also has kind of a raster flavor to it as well, in the sense that there are lots of measurements over a large area. It's 2.5D or 3D measurement. If you throw a few points away because you're filtering it, or you're trying to remove noise, or you're trying to make the data easier to work with by subsampling it, those are kind of raster approaches to data as well. And so it has this sort of hybrid thing going on, but it needed to be its own toolkit and its own library. And so that's how Poodle sort of saw its niche. In comparison to there's a number of other point cloud tools available, open source and otherwise. Poodle's niche in regard to that is very similar to GDAL in that it's oriented towards translation, data management, data access, and geospatial problems, right? And so point cloud has lots of roots in computer vision. It has lots of roots in other kinds of data access, but the Poodle sort of niche is how do we attack geospatial problems with point cloud data, mostly oriented towards data captured by aerial LiDAR sensors, which, governments have been doing for quite a while, and starting to be, street view kind of sensors, or how everybody could potentially have a LiDAR in their pocket with the new Apple iPhone.
It's interesting that you talk about this as not really belonging with the GDAL, with the Geographic Data Abstraction Library. That deals with both types of data, vector and raster. Should we be considering point cloud data as a third geospatial data type?
Yeah, I think so. It's kind of unique and specialized at this point, although as a primary measurement, I think we're going to see more and more of it. People are interested in this concept of, I guess the phraseology right now is digital twins or augmented reality, the ability to capture the scene at a point in time, represent it in a digital space. You have multiple ways of doing that. One is to capture lots and lots of photographs of the area and do a bunch of image processing and photo reconstruction to turn that into 3D data, which again is represented as a point cloud. Another is to use an active sensor like a laser scanner and capture measurements from the scanner to whatever it interacts with. These data are represented as point cloud data and require different techniques to process them, extract them, turn them into consumable information. Again, focused mostly on visualization, I think, for the most part, but a lot of, like we were working with for that Iowa DNR, they were measuring landscape change and, high fidelity topography.
I'd be really curious to know what's in the box. If I go to PDAL.io and I download this software library, this abstraction library, what is in the box?
Some directions. I mean, it's a developer's tool, right? So it's a software library that provides some command line utilities, much like GDAL, right? In terms of allowing the user to compose a pipeline using whatever editor they want. The pipeline is defined as JSON, and executing that across data. There are packages, compiled packages available. You can get those through Conda, and Conda Forge is a common way to get them. So if you're using ArcGIS and Pro in the Conda environment there, you can install PDAL or Poodle and start working with it right there, or install Conda your own with whatever mechanism you want. OSGeo4W also has Poodle available in it, and Poodle is used by the new QGIS LiDAR support that was just recently released and by the QGIS team. So there's a couple ways to get the library itself, but there's no GUI for it. It's a bunch of kind of developer tools for manipulating and processing point cloud data. As a software developer, you can take this library and embed it in your software to add format capability, filtering capability, and so on. As your software adds support for point clouds, you might consider doing so.
You mentioned executables there. Would you mind just telling us, or at least give us an idea of what these executables can do for us?
The main executable is Poodle. PDAL is the main command. And so translation. So there's a subcommand called translate. So it's a Git style if you've used the Git command library application. And so you might say Poodle space translate and take a file in one format, say like a PLY file, which would be like a scan from your iPhone, and turn it into an LAS file that you might send to somebody who can consume LAS or vice versa. So that's kind of a primary niche of PDAL, or reprojecting certainly is a common scenario. Geospatial data, right? We want data in one coordinate system. We want to move it to another. You can do that with PDAL and quite conveniently from the command line, or in this pipeline scenario as well, as I was describing. And then there's 70 plus filters available in PDAL that you can compose into various software workflows that do things like define and remove noise, or define and segment ground, for example, or take point cloud data, grab some attributes from a geopackage file, and then use that to filter out data or interact with data or compose that data to something else.
Is the expectation that all of this kind of processing is done on a personal computer or in the cloud somewhere or in some other special kind of computing environment?
Yes, it's expected. Our sort of normal workflow of operations is to kind of workbench a scenario where we'll try to get something working at small scale on a laptop. And like I had said before, a lot of LiDAR data is not desktop or laptop scale data. It tends to be really large. You want to attack it with some sort of server, whether it's your own server in your back office or the cloud. You need to build pipelines and data flow workflows to attack that data, and it's a lot more convenient to build those on your workstation. And so Poodle allows you to jump back and forth between those quite conveniently. It has support for cloud data services like S3 and Azure Blobs and things like that. So once you're up in the cloud doing stuff with the cloud, it works quite well there. But most people don't natively develop there, and so they want to be able to work on their workstation. And whether you build it yourself or use something like Conda, that's the way to do it.
So when you talk about developing those workflows there, is it simply just a question of taking a snippet of the data you're going to be working with and work on that? Or is there another way of sort of limiting how much work that your workflow is doing?
Yep, you tend to do that, divide and conquer, at small scale, whether you're trying to develop some sort of approach to processing the data, either custom to your organization or custom to what you want to do. Having data organized in such a way that allows you to do that however you want with something like Entwine makes it really convenient, where that data management aspect of the challenge, if you had LiDAR say for Denmark, for example, the LiDAR for Denmark right now is like about 2 terabytes in size. Like, I don't want to manage 2 terabytes of data and figure out where am I located and which data do I open and how do I unpack it and do stuff with it. Having something like Entwine available as a service that I can just connect to and work with it, whether it's at my laptop scale or up in the cloud with something like Lambda or Azure Functions, provides a lot of flexibility. I think there was a question that was kind of glossed over there a little bit in terms of GUI. Why isn't there an open source GUI for PDAL? We've been working with the QGIS team on the LiDAR support. There's been some murmurs about maybe doing another crowdfunding activity there to try to bring some of that sort of GUI capability, how to drive something like PDAL in the context of QGIS. I know from where we sit as the developers of PDAL, that always kind of been considered out of scope, right? We develop PDAL primarily for this. How do we interact and apply geospatial concepts to point cloud data in the context of data warehousing? And so that's, its primary niche and where it grew up. But we completely recognize that people want it more convenient to use, or they want things more packaged up and easier to access. And like they say, patch is welcome. It's open source software, all of that sort of stuff. But everybody's doing their job, and it's hard to get those kinds of things.
So we've been talking about this point cloud data for a while now. Can you give us an idea of what it is? Is it simply just XYZ coordinates? Are there other attributes attached? And if so, what might those other attributes be in a point cloud?
From Poodle's perspective, a point cloud is is a sparse data matrix with an XYZ coordinate attached to it. So one could imagine taking a raster data with cells and representing them each cell as a point, and you can actually do that with PDAL, although that's not like a common point cloud. The data themselves Also include other auxiliary measurements with them. A common one is an intensity. So in an actively scanned situation like a laser or potentially a radar sensor or sonar sensor, there'll be some kind of intensity measurement that says the signal at this point is some relative measure. And that's often used by signal processing algorithms to do various things. It also provides a nice differential of that point relative to all of its neighbors, right? So you can use that information to find edges of vegetation because they differentially reflect laser radiation, say in a LiDAR scenario. The points are often tagged with like a GPS time that says the scanner fired the laser at this point in time. They also have positioning information that tell them about where that is in space, where the scanner was in space when it captured or when it tried to capture that data. And all of these things allow a data processor to do interesting things with them.
Yeah, so I would imagine one of the things you might want to do is start filtering out this data. Perhaps you want to start identifying objects in it. And you mentioned before the opportunity to use things like intensity to figure out, I think your example was the edges of plant material. What options do we have in PDAL for filtering this data and maybe discovering objects or perhaps building DTMs or digital surface models?
I kind of see Poodle as a box of Legos in terms of its filtering algorithms, right? So many people want a composed workflow that does things like classify trees, segments out buildings and edges and roofs, and determines what's surface vegetation versus ground vegetation. And Poodle doesn't see the problem quite like that. Poodle sees the problem as here's a filter that does ground segmentation, or here's a filter that does noise identification of various kinds. And the idea with Poodle is you compose those data processing activities into a series of steps, and you process your data in such a way that you can reuse those. They're called pipelines in various scenarios. So you might write a pipeline, which is a composed workflow for doing noise identification, or you might write one that does vegetation and so on and so forth. Many of the other softwares in the space provide workflows for specific tasks. Because Poodle grew up in a scenario where it's oriented towards data management and moving data, it kind of sees the problem a little bit differently.
I'm going to need a little bit more here because for me that they sound very similar what you're talking about. So running a filter, that sounds like it was the same in both scenarios for me. Can you maybe try and walk me through it again? How is this different from any other sort of geographic workflow where I'm making a selection and then doing something with that selection and putting it somewhere else?
So a specific filter for doing noise identification. So one kind of noise in LiDAR data that's common is noise that is multi-echo reflection below what a ground surface might be, for example. And so a specific algorithm that is sensitive to very low singular points kind of off by themselves below a nominal surface that's available as a single filter in Poodle. And you can use that in combination with other filters for doing various kinds of noise detection. Maybe you have high atmospheric noise that's clustered, or you have structured noise. And those together can be composed into a pipeline. And so this pipeline is very similar in concept to the GDAL VRT in the sense that you define a set of operations or processing steps that are going to happen to the data. Then you execute that across the data and either classify data as noise, or say you're doing some kind of ground segmentation, filtering data, intersecting that data with GDAL raster data or vector data from some source, and take that information and then send it on down the line in some other processing scenario.
So sometimes when we think about huge data sets, we often talk about an indexing or internal tiling of data. Is this the kind of thing that we expect to find in these point cloud data sets as well?
Yes, you're starting to see that data being organized for streaming, for visualization oriented streaming becoming available. We developed a software called Entwine to support kind of rewriting a large collection of point cloud data into a tiled data structure that can be incrementally accessed over the internet. We provided a public data set with cooperation from Amazon and the USGS of all of the USGS data in the United States is available as a streamable format in EPT or Entwine point tile, which then in turn can be consumed by software like FME or Poodle at zero cost to kind of take away the burden of these, multi-hundred terabyte collections of point cloud data when you might only care about the postage stamp that you're familiar with. And so providing it for visualization and being able to look at it in a web browser with something like Marcus Schutz's Poetry web renderer or other web renderers like Cesium, having the ability to put your eyes on the data, interact with that data, and not have to take on the burden of just the large bulk and volume of these really large point cloud collections.
This sounds like the point cloud version of the cloud optimized Geotiff. Am I on the right track here?
Yeah, it's not as refined, let's say, as cloud optimized Geotiff. I think Cog, really hits a home run in its niche because it's still just a TIFF, right? And so the downstream consumption of that thing just depends on TIFF support. And so in Point Cloud, the closest thing to a TIFF we have in Point Cloud is an LAS file in terms of universality of implementation, but there's no geospatial organization indexing incremental access support in LAS. And so it's kind of difficult to do that within the context of an LAS file. But EPT, there's also a streaming point cloud organization from Esri called i3S and one from the Cesium team. All of these provide incremental access to the data. Each has sort of a different flavor in terms of what the use might be, maybe tilted more towards visualization or maybe more towards certain kinds of processing. But yeah, that's the general idea. I want to be able to access a small patch of data at a reduced resolution if I ask for it and not have to take on the burden of terabytes and terabytes of point cloud data.
So I have the feeling that people are collecting more and more of this kind of data. Is that the same sort of feeling that you have when you sort of look out over the industry? And if so, are there any specific industries where you see people are particularly interested in collecting point cloud data?
Yeah, so when we started out doing PDAL, of course, the only big governments could afford to either to pay for the scanning or pay for scanners to capture typically big, large carpets of aerial LiDAR data. And that was going on, certainly until the mid 2015 or so. That was kind of a primary use. Google Street View kind of popularized the idea of, well, we'll put a LiDAR on a car and drive that around and use that for 3D measurement of the street scene and then use that information for various things. And so there's a lot of that activity going on in municipalities in the world, using that as kind of a base, essentially base data for other things to pin to it. You have folks like the Pixelate team, Sean Gorman's team, who are constructing this data using photo reconstruction and then pinning that back to some real world measurement, aerial LiDAR, street scene LiDAR, whatever it might be. And so the volume of acquisition and how that data is acquired and mixed with other data is certainly, velocity of that is increasing. I think that this, just the economics of the scanners and the cost of how to acquire data, the pressure there going down quite significantly is just making this data more available. And then people are looking for more tools to consume it and do stuff with it. I also think that cloud computing has had a really big impact on what people can do with LiDAR data. LiDAR data in 2008 and even in 2021 is not really desktop scale data. You need servers to divide and conquer to attack the data and do stuff with it. Typically, it's very bursty. Like you would burst a lot of computing over the data and either extract information from it or organize it in a certain way and look at it in small bits. But the idea of running processes over a whole country worth of LiDAR data on your laptop is pretty awful.
I really appreciate your honesty there. Sometimes when I think about the way we collect data, like being on the outside of a lot of these different industries and organizations that you're talking about, it feels like the temptation is just to collect as much as possible and we'll figure it out later on. Do you think that's the case when you think about collecting LiDAR data or perhaps even geographic data in general, where it's just a rush to collect as much as possible and we can always figure it out later on? Or do you think a lot of people are going out into the market and saying, well, we have a really clear use case for this and we're collecting it for this particular use case?
My brother does home construction and he has this phrase, which is might as well. While you're there, you might as well do this. And I think LiDAR is kind of a might as well data capture for geospatial. A lot of times you'll get coincident imagery and coincident LiDAR, and that was either thrown in or sold as an add-on as, here's some additional support data and maybe this has some use down the road. The nice thing about LiDAR data is it's a point in time capture, right? It represents the state of the surface, the environment that it interacted with at that point in time. That casts a shadow downrange in terms of being able to use that data in context of other data. And so I agree with your idea that people tend to just capture capture it for convenience and work with it, figure out how to work with it later. There's certainly a lot of that that has gone on. And as organizations are learning how to do things with LiDAR data and how to get value from it, there's a lot of that I think that goes on. But being able to have that LiDAR data and what the state of the environment was at that point in time when it was captured has future value and future use that I don't think is fully appreciated all the time. And a lot of that future value is determined by the convenience at which you can get value from that data, whether it's convenience of access, being able to know where it is and know that it exists. And at least in the United States, having zero cost access to it, I think that is certainly a driver.
I totally agree with a lot of what you said there. When you're talking about capturing the data, I wonder sometimes if we can agree that it's a good idea to capture it. You know, you're there, might as well do it. Let's do it, and we'll figure it out later on, or we'll find a purpose for this later on. Do you see photogrammetry as a competitor to LiDAR, or is this a symbiotic relationship between the two when we think about capturing data?
So Poodle's perspective is they're all point clouds, at least when you take the photogrammetry and compute it to point clouds. I've always seen them as very complementary. The phraseology I use is actively scanned versus passively scanned. So an active scan point cloud for me would be something like a sonar, radar in its own way, or LiDAR. And what that measurement means in the context of that is something quite different than a probabilistic estimate of where 5 or 6 photographs intersect in space, right? So they have different meanings. They're ultimately trying to extract or characterize the same thing. And in photogrammetry's case, you can characterize the surfaces. In LiDAR's case, sometimes you can characterize under vegetation because of the physics of how the laser interacts with the environment, and that might have some value for you. In terms of cost structures, the LiDAR historically has been quite a bit more expensive to capture than, flying a drone at however much overlap you want. And, depending on its use, are you using it for engineering scenarios? Are you using it for measurement scenarios? All of those scenarios have different meanings in terms of suitability for use there, but they're all trying to capture this environment, capture the state of things, and provide more context than simply, a top-down orthophoto or a few pictures of the area. And the idea that you can take this information and then mix it or merge it with other data, which I think is becoming more prevalent, also has a lot of value there. But how you do that with LiDAR data is something different than how you might do that with photogrammetry.
So when we think about mixing and matching data, is this something that is this an option in Poodle? Does it matter where the point cloud data comes from? As long as it's in that format, we can put it in there and start playing with it.
There are some filters in Poodle to allow you to do things like differencing point clouds and see how far apart they might be with various statistics, or try to compute a differential and use that to characterize what might be going on. A number of other libraries have support for such things. Groups like Sean Gorman's group were attacking that problem head on. They were using PDAL or Poodle and Entwine as part of their support to do those things, because that's what they were designed for. And I think this idea of bringing together lots of various 3D point cloud, 3D direct measurement type information, I think is going to become a lot more prevalent as scanners proliferate and people's access to this data just becomes a lot. I don't know if it's going to be more convenient, but it's going to be more ubiquitous. And so people are going to want to be able to take that data that they might have captured and put it into a larger context, whether it's, a scan of their office building or a scan of their bedroom to help them measure, or they're going to put up curtains, like bringing it to the personal level, I think is going to have a lot of impact on these tools and people's use of this kind of data.
So I think what you might be getting at there is the LiDAR that's now available on the latest iPhone, for example. So this is a personal scanner that people can carry around in their pocket and start using. Do you think this is going to push the industry in any particular direction? Up until now, it's felt like we've been talking about larger organizations doing these huge sort of data collection, campaigns, and then coming back to the office and processing it. But when we think about consumers, everyday people walking around with their phones, capturing 3D point clouds, how do you think that's going to either change the industry or perhaps move it forward?
There was a Twitter thread a 3 weeks ago of a group that took their iPhones and a bunch of spotlights down into the Paris catacombs and were just walking around scanning the catacombs as fast as they could. That sort of activity was certainly done with people by people with $100 or $200,000 laser scanners, but it was it was quite an investment as opposed to somebody spelunking down in the caves. And so just the economics of that and the ability for somebody to capture data as fast as they can think about capturing it, it's just going to change the how people expect to capture their environment. As a photographer, I'm not a great photographer, but I know a little bit about photography and composing a picture and how I take a picture of the environment as an artistic endeavor certainly has a meaning, but as a archive or a measurement of the moment that when you capture it has another kind of meaning. The LiDAR scanner in everyone's pocket is very similar to that, but it's a different product. It's a different data. It has different meaning. And how we as a society are going to interact with that at the small scale, whether it's the scale of a room or scanning a person or scanning objects on the table that they might want to 3D print, it's going to create a lot of change.
I keep coming back to Google Maps. For me, Google Maps it changed a lot of things simply by putting people at the center of the map. All of a sudden, they were the focus point, and then they could see the world as they saw it essentially. And I could imagine a similar thing happening here, where people are at the center of this. They're scanning things, they're building digital models of the things that they are really interested in, and then they're going to go out into the world, at least I imagine, and have similar expectations.
Yeah, absolutely. And there's going to be privacy implications from that. Imagine everybody walking around with a LiDAR scanner on their head, on their glasses or something like that. It was kind of poo-pooed when it was just a camera and imagery, but maybe as a continually updating 3D scene capture, maybe people have different sort of privacy concerns about it, or they don't, they want that. It's not clear how society is potentially going to react to that, I don't think, but I think it's coming, certainly.
When you think about problems like that, do you think this is a technical issue or a cultural one?
There's definitely a technical issue in terms of the data volume and how you attack processing that data and extracting information from it and reducing. LiDAR data processing scenario is 90% about data reduction. How do I take this multi-billion point capture of a scene and turn it into data I can measure with, data I can display on some kind of a display or stream over the internet. And so a lot of the activity there is just data reduction and techniques to do that. The cultural activity around everybody having a 3D capture of a scene, whether it's a building, which, okay, I'm not going to rebuild a building per se, but I might take a capture of an object at a museum. Who owns the right to that when I do that? If I'm the one who captures it, what does it mean when I captured it? And then I take it to my 3D printer and print it. Society hasn't gone through what that all means for us yet. And, those are questions that are still to be sifted out.
Maybe there'll be an app on the phone that makes everything a non-fungible token as soon as it's captured.
Yeah, I don't know too much about Cryptoland, but I would say that the idea that the representation of things, intellectual property certainly has had a lot to say historically about derivation and representation of what an object is or what an artifact of art might be, how something was built. And it hasn't caught up. The government and societal aspect of that hasn't particularly caught up to what it's going to mean now for a lot more than simply a photograph, a 2D photograph that I can't completely reconstruct Nefertiti's statue, for example.
So we've been talking about the different ways people might start using this data in the future, might start collecting it, and how it's going to perhaps change the way we're doing things today in terms of data. A wee while ago, I published an episode with Paul Ramsey about GDAL, and we talked about GDAL as being a piece of critical geospatial infrastructure. Do you think that in the future, we're going to have to start thinking about data as being infrastructure?
Yeah, absolutely. If we're going to take, everybody with a LiDAR sensor in their pocket and capturing their small piece of the world and compose that into a larger thing, the responsibility and the ownership of that, whether it as a common, isn't particularly well defined. And I think the current trajectory we are on, the large players are developing archipelagos in terms of this is our view of the world and here's where we might be. There's also kind of licensing constraints going on with various organizations capturing data for governments and then trying to restrict the use of that data or the availability of that data, mostly in an attempt to resell it as many times as possible, but it also in terms of being able to reuse that data in other contexts. And so the scenario I kind of always talk about is the idea of a road capture. For autonomous vehicles, the idea that we would use a LiDAR scanner to capture that base map that we're going to use to build the rest of our maps to do some level of automated driving on. Who owns that? And what does it mean to own that in terms of responsibility chain? If you're driving a car at 80 miles an hour and the data's bad, you might crash somewhere. Who owns that error because the data was captured? Who validates that it was captured correctly? And so I think there's a role for governments who are capturing this data, whether it's large scale aerial data, which everyone wants to know where water is going to flow for flooding, and that's kind of an obvious scenario for this data. But street scene data like Google Street View starting to be captured by municipalities all over the place. Is that freely available data for everyone to use and build on and build out with, or is it limited in some way? What does it mean to take that data and mix it with other data, creating, whether you're using it for creating machine learning models? Who owns those models after you've created it from that source data? The licensing of all of this stuff isn't particularly well sorted out, and its availability as a public consumable good still may be in doubt a little bit.
Those are a bunch of really interesting points that I got to admit I've never really thought through. I definitely thought about the burden of maintenance, right? So when I think about infrastructure, I think about things like roads, pipes, that kind of stuff. In terms of that physical infrastructure, usually there's a really clear chain of responsibility in terms of who is maintaining that. And if it's not maintained correctly, then we have someone who's on the hook for that. But when I think about data in the way that you're talking about, it's really unclear to me who is going to bear that sort of burden of maintenance and responsibility.
Right. And technology wise, having data formats and organization that supports the history and the archaeology of those kinds of things, as point cloud data, certainly we're going to take point cloud data from various sources and merge it together into a common picture, right? And being able to go back in time and figure out what happened or how that data came into being has some value for certain uses. But it also has some policy implications that maybe haven't been completely sorted out. And as the scanners become more ubiquitous, I think this is going to become a challenge, and different countries are going to attack the problem differently. And it's to be seen what happens in terms of how people take the natural world and capture it and use it and consume it in the digital space.
Howard, you've given me a lot to think about. You've been a really amazing and inspirational guest, and I appreciate your patience. This is a subject area that I'm not an expert in, and you've done a great job of slowly but surely walking me through, teaching me about point clouds, what we can do with PDAL, and perhaps what the future might look like as well. So I really appreciate it. Is there somewhere the listeners can go if they want to reach out to you personally or try out the software for themselves, or perhaps just continue this conversation?
So reach out to me personally on Twitter is probably the best way to get me. So I'm just Howard Butler on Twitter. Of course, poodle.io is where you can find the download page to start investigating the software. I would put some shout outs here for the Potree software library, POTREE.org, which is a really great point cloud visualization toolkit that's available out there by a great developer at the University of Vienna named Marcus Schutz. Go to your local government, start playing around with point cloud data. If you just want an elevation model and really high resolution elevation models, that's a great place to start. But if you got an iPhone 12, there's apps out there to start scanning things and then taking that data and doing interesting things with it. So thank you very much for the opportunity.
Thanks again for your time, Howard. I really enjoyed this conversation. Once again, thank you very much to OSGeo for helping make this podcast episode possible. So PDAL is a OSGeo project, and if you want to learn more about some of the other amazing projects that OSGeo is supporting, go along to osgeo.org and you'll find a lot of really, really interesting geospatial software there. It's well worth checking out. So I really hope you enjoyed that conversation with Howard Butler. I will put a link in the show notes to Howard's Twitter handle so you can find him there and continue the conversation if that's something that you're interested in. I also link to the PDAL software and a couple of other things that I just want to briefly mention here that Howard pointed us towards, which I think are well worth checking out. The first one being Potree. So I don't know if I'm pronouncing that right, but it's spelled Potree. And Potree is a free, open source, WebGL based cloud renderer for large point clouds. and it looks absolutely amazing. I also want to point you towards the software that Howard mentioned, Entwine. So Entwine is a data organization library for massive point clouds. And if you go along to Entwine, so ENTWINE.io, you'll find some really good documentation there. You will also find a few really interesting examples of Entwine in action. So one, I'll put a link to the Poetry and Entwine demo, as well as the Cesium and Entwine demo. Really interesting stuff. I think that if you're interested in point clouds, if you're interested in how the stuff is moving around the world, this would be a really good place to check out. Okay, that's it from me. Thank you so much for tuning in again this week. It's much appreciated. I'll be back again next week with another episode, but until then, as always, you're more than welcome to reach out to me on social media. You can find me at Mapscaping on Twitter, and just search for Daniel O'Donoghue or Mapscaping Podcast, something like that on LinkedIn, and you'll also find me there, and I'd be more than happy to connect with you on either of those two platforms. If email is your thing, you can also reach me at info@mapscaping.com, and it would be fantastic to hear from you. So please take the time to do that. That's it from me. We'll talk again next week. Bye.